This lesson is on translating an absolute value inequality. So in essence, we'll be given a story problem or words. We have to translate it into an inequality and then solve. The first couple are going to be pretty straightforward, not really story problems, more just words. So the first one, all real numbers x, whose distance from 0 is greater than 5 units. So we all know that the absolute value means the distance from 0 on a number line. So this one is fairly straightforward because the distance from 0 being greater than 5 units means that the absolute value of x is greater than 5. Now if I had to solve that, remember I would write it the first time as x is greater than 5, and it's an or, so or x is less than negative 5. I'm not going to graph any of these. We know how to do that. Again, this would be 2 points shaded out. For my second one, this one's a little bit more difficult because it's not a distance from 0, it's a distance from negative 7. So the real numbers would be the distance, or the difference basically, between that number and negative 7. So I'm subtracting negative 7, and I want that distance to be less than 3 units. So this is what my inequality would look like. Now we all know when you minus a negative, we're going to keep flip change to give us x plus 7 is less than 3. This is an and question, so to solve it, I would write negative 3 is less than x plus 7 is less than 3. To solve, I would subtract 7 to get negative 10 is less than x is less than negative 4. And that means the real numbers whose distance from negative 7 is less than 3 would be between negative 10 and negative 4. Try these two on your own. For the first one, again, we're dealing with distance from 0, so the absolute value of x would be greater than 10. It's an or question, so my final answer would be x is greater than 10 or x is less than negative 10. For my second, the distance from positive 4, so I'm going to say the absolute value of x minus 4 would be less than 6 units. This is a less than question, so I'm going to write that as negative 6 is less than x minus 4 is less than positive 6. To solve, I will add 4. To get negative 2 is less than x is less than 10. So to answer the question, the real numbers whose distance from 4 is less than 6 units would be the numbers between. This question is a little harder because this is an actual real-life situation, though we can see from the question that they've written the inequality for us. So this is asking about an IQ test performed at a local college, and they've given us an inequality to represent a normal score and asked us to find the normal range. To solve this inequality, this is a less than inequality. I would write this as x minus 100, and then I'm going to write the numerator in the absolute value bracket and write the denominator in the absolute value bracket. This is a helpful strategy to get the absolute value away from the 15 because I can find the absolute value of 15 to be 15. So to solve, I would simply multiply by 15 on each side of my inequality, which gives me the absolute value of x minus 100 is less than or equal to 30. From here, I can now write this inequality 2 times. The first time, x minus 100 is less than or equal to 30, and this is going to be an and question. So I am actually going to write it like this. Sorry, I squished that in there. But I'm going to write it as this compound inequality so that it's easier to solve. So now I will add 100 to all 3 positions. That gives me 70 is less than or equal to x is less than or equal to 130. So the normal range for the IQ test would be between 70 and 130. So you would, in this case, write a sentence that explained that answer. This is harder still because we actually have to write the inequality for these questions. So here we're talking about the difference, or what we're expecting to find from a machine shop. We're expecting to find a thickness of 12 millimeters. And the machine is accurate to plus or minus 0.05 millimeters, or 5/100ths of a millimeter. We want to write an absolute value that will express the true measurement or the true thickness of the piece of metal using T to represent that value. So essentially what we're saying is that if we take the true value and we subtract what we're expecting, that difference will be between plus or minus 5/100ths. So that's going to be the difference is less than or equal to 0.05. So this takes care of that whole plus or minus thing, because now I can write T minus 12 is less than or equal to 0.05, and T minus 12 is greater than or equal to negative 0.05. Again, I could have written this as the compound inequality altogether. I'm going to write this with an and this time to show you can do it both ways. When I add 12 to each side, my first answer is that T is less than or equal to 12.05, or 12 5/100ths. My second answer, when I add 12, I get T is greater than or equal to 11.95. And so my solution would be between, not a negative, 11.95, closed bracket, all the way up to 12.05. Those are the measurements that I can expect from 11.95 to 12.05. Try this one on your own, then press play to see how you did. This one is very similar to the last question that we did. Here we're measuring 8 grams of a compound. The scale is only accurate to plus or minus 0.1. So again, if I take the true mass and I subtract the 8 that I'm expecting, that difference should be less than or equal to 0.1, or 1/10. This time when I write it, I'm going to write it as negative 0.1 is less than or equal to x minus 8 is less than or equal to positive 0.1. When I solve, I will add 8. My resulting answer is 7.9 is less than or equal to x is less than or equal to 8.1. So the true mass would be between 7.9 and 8.1 inclusive.